Hi friends, today let's learn aldol condensation. So aldol condensation is one of the important chemical property which is shown by an aldehyde or a ketone. But still there is an important point you have to memorize, that is aldol condensation is a reaction which is shown by an aldehyde or a ketone with alpha hydrogen atom. So let's see what is alpha hydrogen atom by taking a small example like ethanol, CH3CHO. So alpha carbon is a carbon attached with the functional group such as CHO, or if it is a ketone, CO. And the number of hydrogen atoms attached with that alpha carbon is called the alpha hydrogen atom. So aldol condensation is a special reaction which is shown by only the aldehyde or a ketone which contains alpha hydrogen atom. It means if we take HCHO, there is no alpha hydrogen atom. Why? Because only one carbon, that is the part of the aldehyde only. So there is no alpha carbon. So this case we cannot write aldol condensation. Similarly, if we take benzaldehyde, there is alpha carbon. This is the alpha carbon, but there is no hydrogen atom because all four valencies are satisfied. So this also will not undergo aldol condensation. So first I'll take ethanol to show the reaction CH3CHO, and to undergo aldol condensation we need two molecules of aldehyde, ethanol plus ethanol. So to understand the reaction I'm just writing in structural representation. I'll write it CH3C double bond OH, the first aldehyde. Now the second aldehyde is CH3C double bond OH. And the reagent which we are using in aldol condensation is dilute NaOH, or we can use KOH, alkali. So the reaction is the bond, the double bond, carbon oxygen double bond in the first aldehyde breaks because oxygen is more electronegative. So the shared pairs of electrons are moving closer towards oxygen. So oxygen gets a partial negative charge and carbon gets a partial positive charge. So double bond changes to single bond. By the time the alpha hydrogen atom from the second molecule, this is the second molecule, this is the first molecule. The alpha hydrogen atom, alpha hydrogen atom from the second molecule eliminates as proton H plus. That proton will attack with the oxygen atom of the first aldehyde. It means we can write as CH3, the second carbon is CH, and which is connected to the double bond oxygen and hydrogen OH. And now the first molecule will connect with the second molecule through this alpha carbon. So out of 3 hydrogen, 1 hydrogen went, so that 2 hydrogens are there. So we write CH2 and the rest is C double bond OH. So in this product, if you are looking, there is an alcoholic group. Alcohol is ending with OL, and there is an aldehyde group. So both the functional groups are there. Both aldehyde and alcohol is there. That's what this product is called, the aldol product. That is what the reaction name is, aldol condensation. But this reaction is highly exothermic, so that it liberates water. So let's see from where the water molecule is eliminating. We know that water has H plus and OH minus ion. So OH minus ion is eliminating from this part and H is removing from that alpha carbon, the same alpha carbon. So before there were 3 hydrogen, from that 1 hydrogen has gone. Now the second hydrogen, this hydrogen, will be going with this oxygen as water. So the remaining is CH3CH, then we put a double bond to satisfy the valency, then CH, C double bond of H. So this is aldehyde and also there is an alkene. So this is like an alkenyl product. It's an alkene with alkenyl. So for conversions and all, if the question is like ethanol to the product name of this the first product is 3-hydroxybutanol, and the last one is but, this is 1, this is 2, so butenol. So if the conversion is like ethanol to 3-hydroxybutanol, you have to check like this. Ethanol has 2 carbon. Why? Because eth, and butanol has 4 carbon. So carbon number is doubling. Normally in organic chemistry, carbon atoms are doubling in Wood's reaction. But the Wood's reaction speciality is we are getting hydrocarbons are the product. But this is not a hydrocarbon, it contains functional group. And the functional groups are two. One is aldehyde, another one is hydroxy, it represents an alcohol. So both aldehyde and alcohol are there in a compound with the doubling the number of carbon atom. That is only one reaction, which is aldol condensation. Similarly, if the question is ethanol, butyl-enol. In this case, an aldehyde and an alkene is there. So that doubling the number of carbon atom is giving only this reaction, which is aldol condensation. So this is not only like complete the reaction, you have to learn like conversions as well. So here I have taken same aldehyde. Two molecules of aldehyde, both are ethanol. So if same aldehyde molecules are taking part in aldol condensation, that process is called a self-aldol condensation. Similar molecules. But there is a different form which is called a cross-aldol condensation. So in cross-aldol condensation, we have to select two different aldehyde. For example, I am selecting CH3C double bond OH, ethanol, and propanol, CH3, CH2, C double bond OH. Now two different molecule. Reagent is dilute NaOH. Okay. So during the reaction, again the same reaction like C double bond O breaks. Here you have to identify this alpha hydrogen atom, the second molecule. This is the alpha carbon atom. So this is the alpha hydrogen atom. So this comes here with the oxygen atom so that the carbon double bond oxygen breaks. So CH3, CH, single bond OH, and that carbon attacks with the alpha hydrogen, alpha carbon atom, which is CH. It was CH2, now it becomes CH. That CH has C double bond OH. That is a functional group. Now this CH3 we write as a branch. Don't put, you don't keep it in the straight line. It comes as a branch only. And now as this reaction is exothermic, water is getting eliminated. Again from the same way, OH from here and H from the same alpha carbon. You don't take hydrogen from the opposite side. I mean from this side you don't take it. So it gives CH3, CH, double bond C, H has gone, CH3 is a branch, then C double bond OH. So this is how we are writing cross-aldol condensation because two different aldehyde. Actually, practically if you are doing this reaction, let's take ethanol as A, propanol as B. If you are doing A plus B, we get AB product. But if you write B first and then A, then we get BA product. AB is different from BA. When you write the chemical reaction, you will understand both these products like AB and BA are different. And in the reaction vessel, if millions of reacting molecules are there, A can combines with A itself, forms AA product. Similarly, B combines with B, forms BB product. It means chance for getting self-aldol product also if you do cross-aldol. So these two are cross-aldol product and AA and BB are self-aldol products. So totally we are getting 4 products if you do cross-aldol condensation. So I hope you understood. So now let's take another example which contain a ketone. One ketone also I'll show you. CH3 C double bond H. It's an aldehyde plus CH3 C double bond CH3. It's a propanol. So the same process, carbon oxygen bond breaks. Why? Because this is the alpha carbon. There are two alpha carbon in this case. Both the alpha same priority only. So one hydrogen will be leaving from there to here. We get CH3 C single bond OH H. Rest is CH2 C double bond CH3. Again the same way water elimination is taking place. Why? Because it's highly exothermic. So we get OH and H gets eliminated like this. We get CH3, CH, then double bond CH, C double bond CH3. So the reaction takes place in this way. So this is how we are writing the reaction. So you try to understand some points like the reagent is dilute NaOH. Don't write concentrated NaOH. Why? Because if we write concentrated NaOH, we get Kennesaw reaction product. And also, how many carbon atoms we are taking per molecule in the reactant side. In the product side, always it's double the number of carbon atom. And if it is aldehyde, we get aldehyde and alcohol is a functional group present in the product side. And later, water elimination is giving an alkynyl. So these are some of the important points you need to keep in mind while learning aldol condensation. So I hope you understood. Thank you.